Okay, hello everyone. Welcome to the CE community call for this month, April. This is being recorded and we'll post it to YouTube so that if anyone wants to view it offline and see what we're going to show and talk about, then it's there. So this month we're going to have a bit less of me talking about development things and roadmap things, and a bit more of a demo and discussion from others. So we're going to start off with Mike Frisch giving a demonstration and talking about the SCS Build client, which is a standalone client tool for remote building containers. Adam Hughes will give an update about work to do with generating software bill of materials for SIF containers. And then I'll get on to the CE release and development news before we go to any other business. So that's the order of things today. So I'll pass over to Mike straight away, and he can tell us all about the SCS Build client.
Thank you, Dave. So anybody that was around for the meeting last time, we announced the SCS Build tool, and I at the time promised to do a demo. So here it is. During this meeting, I'm going to show off a little and hopefully spark some interest in automation of SIF image builds. This probably is something useful to many people's workflows. So I hope to kind of get the message across and hope that you can get something out of it. So to recap, SCS Build was created to allow easy automation of SIF image builds, mostly in CI/CD environments, but it also allows building SIF images from workstations running Windows, Mac OS, and other environments where either Singularity is not supported or not installed. SCS Build is part of the SCS Build client package on GitHub, so it's completely open source. The code is basically the exact same code that Singularity itself uses to invoke the remote builds. So it should be familiar if you've looked at that before. So first off, I'm going to share my screen here, and we're going to do a quick little demo of building from Mac OS. Okay, let's do this one. Sorry, just fighting Zoom here. Okay, can you see my terminal clearly?
Yes.
Great. Okay, so as I mentioned, I'm going to do a build on Mac OS. So I've set up my environment here. Basically have a local Singularity enterprise installation, and I'm going to invoke the remote builder there and do a build from my Mac OS machine, just to show that I'm on Darwin. So I'm going to source my environment variables, and I have a little test there. Don't want to show you my token, but just to show that it's set. And then I'm just going to do a Docker, sorry, I'm going to type Docker run the SCS Build OCI image is hosted on Docker Hub, by the way, and I'll get into that a little bit more later. I'm going to be doing a build of an Alpine SIF image from the upstream OCI Alpine image. And I'm going to push that to my local installation, as I mentioned. And away we go. So anybody that's done a remote build using Singularity will recognize this is the same output. As I said, it's the same code being used. So that was pretty quick. I'm going to jump over to my browser. Hope you can see this. And just to pop back here, I mentioned that I'm going to the project MF and the repo demo 1 Alpine. So I'm going to go demo 1 Alpine here. And there's the build. You can see everything checked out. So that's easy enough. If you've done a Singularity build -R, you'll be familiar with the whole workflow basically. So this is doing it from my Mac OS machine without Singularity installed. It's pretty straightforward. So you could use the same command line to do a build against cloud.sylabs.io. In that case, you only need to specify your project name and your repository. Obviously, the default is cloud.sylabs.io. And again, using your access token that you generate from the access tokens functionality in cloud.sylabs.io. The SCS build command and actually the SCS build subcommand both have online help, and the container is documented as well at Docker Hub. So if you need to use some of the more advanced features, you can notice I use skip verify here because I'm using a private CA, so I have to ignore the local TLS certificates. All right, so now I'm going to kind of jump forward. Actually, before we go, is any questions about what I've done there? I think it's pretty straightforward. All righty, so now I'm going to move on to doing a similar build from Podman on a Linux machine. So I'm on my Ubuntu server, as you can see, with Podman installed. And I'm going to source my environment the same way. And just making sure my output directory doesn't already exist. In this particular example, I'm going to be downloading the build artifact locally. So I'm going to do podman run. Busy box this time. That should do it. I messed something up there. I forgot the invocation of the image itself. So as you can see, this one is actually running against cloud.sylabs.io. And if you're familiar with podman and the volumes command argument, I've basically said that I'm going to have the local directory, SIF, mapped to the directory output from inside the SCS build container. So when I specified the destination of the build artifact, I just specified output / busybox_latest. And here it is. Should be no surprise. Valid SIF file. So that's all interesting. Most people will already have Singularity CLI, so it's probably not that useful here, but the particularly possibly useful use case is to use it in a CI/CD workflow. So obviously, since it's an OCI image, you can invoke it through GitHub Actions, GitLab, or any other CI/CD system that can invoke an OCI image. So in the third part of the demo, I basically created a local GitLab installation. And within that, I'll show you the project I created. I have a simple project here, just test PRJ1. And it has a def file for building a Singularity container, obviously, again, bootstrapping from Docker with the latest Alpine OCI image. But the important thing here is actually having the build invoked through the GitLab CI/CD pipelines. So in the source code for the SCS build client, we include this example the GitLab CI YAML file. And I've modified it slightly just for my environment, in particular, just setting the tag appropriately if I'm on a branch or on a main branch of the repository. And you can see similar invocation here. Again, skip verify because I'm building against my local Singularity enterprise. And in that case, I'm going to be building Alpine to the project MF and the repo default Alpine. So what's going to happen is I will go into SPOJ. I've basically cloned my repo here, and this is the def file that you saw in the GitLab, and I'm going to add a post section. I'm going to commit that change. Push that change up. Then I'm going to go back to my GitLab install. You can see that my commit has been noticed and it's pending the build. So it'll only take about 10 seconds. So you can see it's just gone through the build process, and again, similar output to what you've seen already in the last demo. And because it's pushing to the library, I'll go back to my library and my local install. Remember, this one was going to default Alpine. And there's the container that it just built. So obviously this is something that might be useful for people to automate their builds. You could even automate this through like a simple cron job. And because SCS Build obviously doesn't require root privileges, you can use a local cron job to do your builds automatically. As mentioned, we also provide a sample file for GitHub Actions. And through a little bit of fancy coding of the build context, you could actually have it so that it automatically signs, verifies, scans, encrypts any of the build artifacts before they go to the next step in your CI/CD workflow. So as I mentioned here, this file pushes to the library, but there's nothing stopping you from having it downloaded to a local file store within your CI/CD environment. And then at that point, you could pull a key material from a central key source and sign the CIF file that was generated through this automated build. So there's an endless number of possibilities there, what you can actually do once you have this in your CI/CD environment.
Mike, Dave Dyser has got his hand raised. Dave, do you have a question?
Sorry, I don't have my Zoom window. Here, go ahead, Dave.
I'm still wondering though, you could do these also with the Singularity build command. So
yeah, nothing changes there. This is more like a lightweight. You don't need to install Singularity within your CI/CD workflow. It's just a wrapper around basically the the Singularity build remote command.
And it's like smaller. It's a smaller tool, right? Because it's built on the library that Singularity imports.
Yeah, exactly. Yeah.
Yeah, so I mean, what we kind of see is, you know, in GitHub issues and things, we quite commonly see people who report issues installing and running Singularity under Docker, and that's what you're generally using in CI pipelines now. So this is just a kind of more friendly way to do that. And there's you know, for looking at CIF files, there's the CIF package can build a CIF tool. Now for doing builds, you've got this tool, so you can kind of be more flexible, and you can work from other machines for these types of operations. It's kind of important now, especially as you know, more people have M1 Macs and things, and they want to keep repos on there and develop dev files and stuff on there. It makes it easy to then go off and to build, because it's a binary that you can use there.
Yeah, I'll put in a word for the Darwin build of this. I think it's cool to be able to, you know, it feels almost like being able to do this natively from a Mac, being able to build an image and push it up. So for folks who are, you know, they're not running the same type of system as they're ultimately going to run the container on, this is, you know, pretty useful. And I think what we're starting to see is a lot of people are starting to use automation to build, and having to install an entire runtime to do a build kind of runs counter to what the rest of the ecosystem is doing. So this is kind of one way to bridge that gap for HPC users who are forward leaning into automation workflows, and really makes it quick and easy. It's faster to start because it's a really tiny container to get going, and then the builds run super fast up in the cloud as well. So yeah.
Any other questions at this point? That's pretty much my wrap up here. If you have any questions, I'd be happy to answer.
Could you bring up the GitHub repo where this is, just so we can show people where the code is?
You're jumping ahead of me here. Yeah, so it's under Sylabs SCS Build client in GitHub. And here's the example invocation, a little bit of blurb about the GitHub Actions and GitLab configuration files. Those are under examples. And yeah, that's pretty much it. You can submit issues here. We encourage anybody to join our community Slack. And there's a Sylabs Cloud channel there we can discuss there. Be happy to have any PRs, any issues that you can report. Yeah, anything like that. Binaries are also available here, I should also mention. If you go to the releases, like Adam mentioned, we have Darwin for ARM and AMD, and Linux for ARM and AMD, and Windows as well. So you can run this on natively on Windows. If there are no more questions at this point, I will stop sharing and we can move on. Thank you.
Thanks, Mike. I guess we'll move straight into what Adam's going to talk about then, software bill of materials and exciting stuff like that.
I don't know if anybody's called SBOBs exciting before you, but yeah, so I guess continuing on the theme here a bit of, some of the really large users we have of Singularity CE and also Singularity Pro are really starting down this path of automating. And one of the reasons they're doing that is not just to gain, productivity and get things done faster. It's also increasingly in, regulated industries, something that has to be done. They have to automate, and there's starting to be this need to put kind of, security procedures in to scan containers, to have kind of a story about the supply chain of the software going into all of their environments. So I think in the cloud native world, this is a problem that everyone woke up to in the last couple of years. Even the White House in the US put out some, executive orders around saying you will do supply chain security if you want to sell into the US government in the coming years. So we're starting for, the first time in a while to have non-technical people talk a lot about security and even supply chain security around software. So Singularity is no different. And I guess there's two ways to look at this. Singularity as a tool is clearly built with a supply chain. So, Sylabs as a company, we're starting to get asked about, what's the state of that supply chain? How can we have confidence in it? In open source, I think we want to have a great story there about, here's the material we can provide, here's how it's built, here's the sources. Hopefully, down the road, here's how you can reproducibly build one of the releases that Dave ships. But there's another story to Singularity, and that's that it's a supply chain itself. So obviously, like Mike just showed there, you can also build software with Singularity. And so it's natural to ask the question, if I want to start doing supply chain security in my performance computing environment, how do I do that? A lot of the tools today on the leading edge for generating things like a bill of materials work very well with Docker images. So that's certainly an approach to use OCI-based tooling up front, and then if you want to use Singularity to pull those in on your cluster and run them, you can do that. There's a few gotchas, but that's something today. But we have seen this ask for kind of natively supporting some of these workflows within with CIF images. So if you're starting to build with Singularity, you're publishing a CIF image, either to the cloud or on a parallel file system, wherever it is. how can you take that and start to get a supply chain story around that? So the first step really, when you look at your supply chain, is to start documenting it. And at the very start of that process is just understanding what's in a container once it's built. So the general consensus of the first baby step to take down this path is really all about generating this bill of materials. And so for us, looking at SIF, I think the obvious question was, well, how can we generate a bill of materials from a given SIF image? Whenever I, most developers were, certainly myself, I pride myself on being pretty lazy. And the first thing I ask when we get faced with a challenge like that is, well, what can we leverage of, work that's out there already to do this type of thing? And the leader in open source for, taking that first step, generating a bill of materials, is really a company called Anchor today. And in particular, their open source tool, SIFT, SYFT. Bit confusing talking about SIF, the Singularity image format, and SIFT in the same sentence, but the short of it is, what we're looking to do is really to integrate into SIFT support for generating bill of materials directly from SIF. So this is all work that's being done in open source. There's actually a couple of open source PRs that have been opened in the Anchor, 2 of the Anchor repos with regard to this. I think Dave has added a link to the kind of umbrella issue for that in the Anchor SIFT side. But yeah, at the end of the day, I mean, the first goal for us is how can we, really enable users to generate that bill of materials quickly and easily once they've got a SIF image built. So that's work in progress. We probably on the next community call might have a demo even to show for that. I think we've got some technical challenges to work through in the implementation side to make sure that we can get that upstreamed into the Anchor side of things. And then lastly, I'll mention too that we've also been taking the same steps to kind of document the releases that we're publishing in open source already. So we do not have this yet for Singularity itself, but for SIF, the SIF tool repo, that actually does have a bill of materials that's being published with each release now. Not signed, so it's kind of early days, but in the coming weeks, I think we'll be adding signed attestations going forward as well. So not only will you be able to understand what's in there, you'll be able to cryptographically verify that it was Sylabs that asserted that during the release process. And then the other one is around Mike's SCS Build tool that also has bill of materials published with the latest release. So that's really the 2 steps forward we're taking. Open source binaries we're shipping themselves, making sure we've got bill of materials there. And I'll give a quick shout out to Vadim on the Sylabs team, who's been leading that effort, getting that work in. Expect to see him working on the signed attestations going forward. And then Dimitri from our community is actually working on the Anchor part of that, integrating with SIFT, so that we can put them ultimately into the build process for Singularity containers. So yeah, that's really kind of the overview of where we're going. Anybody have any questions on that? Supply chain security isn't the sexiest topic in the world, but cool. All right, DT, I'll pass it back to you.
Great, thanks, Ed. Look forward to hopefully seeing a demo next time. That'd be great. Fingers crossed. Okay, so let's get on to the SingularityCE updates. If I can share my browser again. Since we last spoke, about 2 weeks ago, there was a CE 3.9.7 release, and this was a bug fix release. The things this did was support the latest version of NVIDIA Container CLI. The 1.8 release of that needed a change the capabilities that Singularity allows it to use. and also a small bug which just prints a messy panic instead of a nice error message if you try and use the cgroups function with an invalid file. So those were fixed in 397. The NVIDIA container CLI fix is notable because we posted an article and we shared it on social media and stuff about using Singularity CE with GPU containers inside the Windows subsystem for Linux 2. In order to do that, you have to use the NVIDIA container CLI method of setting up the GPU with Singularity. And if you get that package on Ubuntu, the default Ubuntu WSL2 environment, then you're going to end up with 1.8.0. So you kind of need that bug fix if you're working in that kind of environment. We will shortly have a 398 release. If I hop across to the release 3.9 changelog, which isn't complete yet, then there's going to be a bug fix. So Vanessa, who's well known in our community, kindly contributed a fix to avoid truncating environment variables with commas when they're used with the --n flag on the CLI. Basically, the way the handling of --n on the CLI was written, you couldn't set an environment variable with a comma because it was just kind of very naively splitting lists of environment variables based on a comma. So you get strange behavior. So Vanessa actually brought over a very similar fix to something that she'd done for another project. And that will be in the next release. Not listed here because it's in a PR at the moment to update this changelog, is that 3.9.8 will bring a fix for an unfortunate issue pushing to the library. So in 397, unfortunately, there was a hole in some testing, and we had a bug where push might report a malformed URL when the library URL you're pushing to isn't actually incorrect. There was a workaround, and I emailed the mailing list about that to put an extra slash in temporarily, but this will be fixed very shortly in a 3.9.8 release as well. And we'll get in the final changelog there. What I do want to talk about a little bit is what's at the top here, this known issues portion. So Go, the language, releases regularly, and their policy is that they support the latest 2 releases with security fixes. So our policy is to support those releases of Go. And this means that when a new Go version comes out, usually Adam jumps in quite quickly with PRs to bump our CI and fix any things which are related to changes in the Go language or the Go tooling. Now, we have a feature in Singularity CE where you can build and use plugins. So you can write some code to change the behavior of Singularity at the CLI level or the runtime level. And honestly, the most commonly used one of these is a log plugin. We've got an example which writes some stuff to syslog when someone takes an action with Singularity. Now, plugins in Go are quite difficult to work with. Go has extremely strict requirements on what kind of dependencies and Go version and everything your plugin was built with versus the main program. So it's not quite like other languages where a plugin can be provided quite separately and still work. It really means that you have to have a very consistent build environment between the Singularity main code and your plugin. Now, there's been in the past kind of workarounds so that we can build plugins in a directory that isn't inside the Singularity source tree. Now, unfortunately, the way we kind of did this was to pass certain flags to the Go compiler and the assembler to ask them to strip out paths and replace paths which are Go encodes in the plugin and the main Singularity binary. And those things are how it knows whether they kind of match up. With Go 1.18, that approach no longer works. And in the Go GitHub repository, I kind of opened an issue and things, but looking around, it kind of became very clear that what we were doing to make this possible just isn't something that's going to be supported by Go. So that's a long-winded way of saying that if you use Go 1.18 with SingularityCE 3.9, you may find that some plugins won't build, or they will build, but they will fail to load after they're built. Now, in 3.10, what we're going to do is actually go back in time and require that plugins sit inside the Singularity source directory when you build them, so that we don't have to use this flag and stuff which doesn't work properly in Go 1.18 anymore. But if you're using SingularityCE 3.9 and you're building a plugin, you should stick to using version 1.17 of the Go toolchain. This likely affects a few people who are potentially building the log plugin. They might find the log plugin actually builds with 1.18 because it's rather simple. But when we move up to 3.10, building the plugin will be slightly different. Any questions on that bit? Okay. Outside of this, development has been relatively quiet in terms of features because honestly, this Go 1.18 change has consumed a lot of time trying to pin it down. And we've also been working to beef up some of the testing and so on related to avoiding the library push issue that I mentioned and so on in future. What has happened is that there's been a bit more work to get into the master tree, the experimental C groups functionality for unprivileged users. That's now, if you build from the master, you can use that functionality that I demoed in the previous call. And that will soon be worked up so that we'll have then the flags I talked about. So you can directly on the Singularity CLI ask for restriction to a certain number of CPUs or memory limit and so on without having to write your own C groups TOML file. It'll be easier to implement those restrictions just with flags. So that's the next bit I'm going to be tackling, and we just kind of continue to move along on the roadmap for 3.10, and 3.10 is expected to come out in mid-May. Any questions on that stuff? If not, we'll just open the floor to any kind of general topic anyone wants to bring up. Any questions you have about anything to do with Singularity, we'd be great to chat about those now.
Yeah, I wanted to have a discussion on your roadmap for doing more OCI support and for switching to using OCI or the same libraries as Podman is using the OCI infrastructure, right? Already have a PR for 3.10 that's been integrated that does that part, and I'm asking for the motivation behind it. I'm in particular Cedric has been very hesitant to go this route, and so I'd like to see what you're like. For example, my reaction to the first thought is, why would you want to use the same thing that Podman's using? Why would people want to do that with Singularity instead of just using Podman as far as the OCI commands? And then of course they don't currently have OCI in SIF, which is part of your 4.0 plan. But what is your thoughts on that?
Okay, I can talk a little bit, and Adam might want to join in as well. So what we really kind of see is, if we look out at the general usage of SingularityCE, and also if we talk to people who are using Pro, then many workflows are primarily around running OCI images. Okay, maybe they build them in-house, OCI images, or they get images from Docker Hub. Now, Singularity has, since one of the 3.x versions, kind of stated that it's OCI compatible. And there are kind of two areas in which you can consider this. The first area is the Singularity OCI command. And what the Singularity OCI command does is kind of replicate the exact life cycle of a container that is in Docker, and runs a container according to a config JSON file, which is the OCI format for the kind of low-level setup, instructing how that happens with a container. Now, Singularity's OCI engine isn't completely full-featured. It required privileged user to run it. You can only run it as root. Now, this kind of really quite limits its functionality there for most users who would have Singularity. It's not something they're going to be able to use. So that Singularity OCI portion was almost sort of irrelevant to most users. Mm-hmm. But what people do want to do is genuinely run Docker images in a way where they don't have to think about the mismatch between some kind of Docker concepts and Singularity concepts. And Singularity doesn't do certain things the same way as Docker, and things like exact handling of environment, what goes into the container, and so on. And really, these differences have very good background in making it possible for people to use containers back in the days of RHEL 6 everywhere, and so on. But we're moving to a situation now where we have the opportunity, as HPC centers move to newer distributions, to make use of the kernel facilities and things like user namespaces, and be able to replicate the experience of Docker more faithfully, so that containers can run exactly as you would expect them to with Singularity. You wouldn't have issues with some of the behavior that we have now. But what we have to be mindful of is that lots of people are using Singularity containers, which are not built from Docker containers, which are built from scratch, and we have to remain compatible. So if you want to provide genuine OCI compatibility, not just at a kind of technical level of implementing the 3 specs in different places, but kind of what a user expects when they come and try to run a container, then we could modify the Singularity current engine to do all of that stuff and put a lot more conditional work and things into it. Or we can use one of the very well tested, very well maintained OCI runtime engines, and basically make that work with the command line interface that people like that Singularity has. Now, if you've got tools like Podman and so on, by default, you're not going to have various mounts and things. And for people using CI tools or who are really invested in automation and using runtimes day by day, they might not mind this. It doesn't really matter to them. But for just a general user on an HPC system trying to put a program into a batch workflow, they know how to do it with Singularity. They might benefit from better compatibility, but they don't want to know about having to do, map volumes indirectly and worry about all this stuff. So the idea is that we provide the means for people to get a genuinely compatible experience using very well tested and very well maintained low-level components, the runtime, while we continue to support the needs of users at the kind of front end, what they expect there, and have compatibility with existing Singularity images for people who have those or want to continue using Singularity very natively. So this is kind of the justification. I don't know if you have any questions there, Dave, or if Adam wants to talk about it.
So I just am trying to summarize. You're saying so it will behave very much like Podman, except that you've got a few extra things like some Singularity adds some extra mounts by default, and maybe some other conveniences, but otherwise it's pretty much like Podman.
I mean, you could argue that it is getting close to that in this intended mode, but SIF is a core thing, and using SIF in the manner we do today, where it's direct mounting and we support the signing with embedded signatures and all that stuff. And really, it's not just kind of a few flags and things and a few mounts. There's quite a lot of complexity, I'm sure you know, in how you can set up your Singularity conf and how people tailor things to systems, how they've got AutoFS on clusters, a ton of stuff, which are a lot of edge cases. And there isn't really a guide for people to say, okay, I do all this stuff with Singularity and it works. I want to have exactly the same experience going across to a different OCI runtime. It's not a clean mapping. So this is where we will be doing work so that we preserve the experience for people.
Yeah, I'll jump in too and say, like, from a less technical point of view, one of the things we're doing in the Singularity community is really starting to listen to users and what they want and have that drive the roadmap. So when we go out and we talk to an open source in these calls, and also the feedback we get from pro customers, this is one of the big challenge points. A lot of them have a lot of users who are familiar with Singularity, and they're they've even seen some messaging in the past saying there's perfect compatibility with Docker images. They'll go out and they'll try and run, the latest, machine learning tool, classification tool, whatever it is, it won't work. And that just creates confusion. So starting with that as the goal of really, what does that user want to do, is kind of where, that whole roadmap that DT laid out came from. What we've done in the past, and I think Singularity 3.0 was this. Singularity 3.0 was something that was driven by engineers. So we kind of, if you looked at what happened between 2x and 3.0, actually there weren't any features that were new and exciting for users for the most part. And that's the feedback we got. Okay, great. You guys did a bunch of work and I can't even tell the difference. And actually some of the stuff doesn't even work now. So with the move to 4, the goal here really is, okay, what do Singularity users expect? Well, they expect their current images keep working. They don't have to learn a new set of tools. Their current workflows keep working. But as they're trying to pull in these, forward-leaning OCI-based workflows, and we are seeing that as a common thing. Automated pipelines building containers that are shipping into Singularity runtime. Trying to solve that of just making that work without that user having to do the mental load of, okay, either I have to switch runtimes to run this, I have to learn 2 runtimes and maintain that in my head now, or I have to jump through these hoops to get this image to work, and you kind of end up having to upskill on that. So the goal in abstract really is solve that. The engineering work that goes on in the background is, not to diminish it at all. There's considerable effort that's going to have to go into making that work, but that as a goal, I think, is our driving principle, and that's really that comes from listening from feedback from the community. As this is the number one thing that people struggle with today, and it's becoming more prevalent, not less. So. I think it's great that a lot of the tech's lining up on the back end. So some of the limitations we've had, like Dave mentioned on the kernel side, make it tough to implement some of these things. But that's changing over time. So we've got a real opportunity on the engineering side to solve that user need now. I think DT's done a great job of articulating that vision and refining it as we go along, and note what's going to be hard to do from an engineering level. But I don't think the goal has changed. At the end of the day, it's really to support those kind of hybrid workflows and make Singularity continue to be relevant in that ecosystem of rapidly evolving tools.
So one thing that OCI requires is having new UID map and new GID map set up, right? And if you're going to be, so that I don't, it's unclear. Maybe at some point everybody will have that by default, but that's a concern to have. I mean, one thing is though, you're not planning on 4.0 to changing the default operation as far as even in the CIF images of having just the one user ID, so it can be completely unprivileged. Is that right? Is that you're going to have an option to be able to have a complete OCI in a CIF file? Is that right? It'd be optional.
So the intention is that definitely 4 will not be a kind of a default thing which is impossible to run without the sub-UID, sub-GID stuff, right? It's we're very concerned with maintaining the experience for people using it. The idea is with 4 to really bring in more possibilities that people can exploit if their systems support it. We'll see how the kind of uptake is on that to kind of direct it past that point. With regard to the sub-UID, sub-GID stuff, this is something now where there is some movement on it. So it looks quite possible that Red Hat Enterprise Linux 9 will support bringing in these sub ranges from LDAP and so on, which will be a big change. And what we want to do really is get into a position where we provide the way to kind of benefit from this as people reach that point in their deployments on their HPC system. So they can kind of, if they're working on systems that supply these things, they can use them and they can benefit from them, and they can investigate it, and maybe it doesn't get onto their big HPC platform for a couple of years, but it's there for people who need it in these CI workflows, which even very traditional HPC research is moving more towards, and so on, as Alan mentioned. It's there for people to use and benefit from.
Yeah, and I'll just mention too, like part of the point of putting out a roadmap that extends, that far into the future is really to get these types of discussions going, right? About, well, how will this work? And for somebody supporting it, what do I need to have on my system? And if that isn't reasonable, giving them a chance to telegraph that way before, we ship a release. So that, to us, having that roadmap out there and having it be really transparent about here's the goals and here's how we're planning to get there is part of that to stimulate the discussion. We're a ways from starting to work on 4.0, but what you're starting to see, if you're watching GitHub, is us building some of the foundation up for this slowly, and adding it in so that you can start to play with it and start to break it and give feedback and maybe jump in and help us build it. But yeah, I think that that's really the point. That's really where we're at with 4.0 is having those discussions, and yeah, so love to get anyone's feedback in there for sure.
That was helpful. Thank you. I don't know if anybody else has something else they want to bring up. Otherwise, there's one more separate but maybe related topic I could bring up. And that is that in the Aptainer side, I am making good progress on using squash views for unprivileged SIF mounts. So I expect that to be coming soon, just to let you know. Also, it's actually, I mean, I have it working in a PR, but before that, I'm putting in something that was actually a lot harder to develop, which is to have a consistent way of securely searching for tools in the path. So this is one more tool that was being searched for in the path, and instead of adding one more configuration line item in the configuration file where it's searched for it at compile time, went through and changing everything to search at runtime, but with a single path, and that was actually quite a challenge. So it's waiting. My PR for squash fuse is waiting on that.
Sorry, Dave, did you say there's a PR open for that? I'd be interested in taking a look at it.
The squash fuse one isn't open yet. The well, there's a sort of scratch one in my own GitHub org. But the searching for path, that PR is open. The searching, so you can look at that.
Yeah, I'm aware of that one. With regard to the squash fuse stuff, so Adam, there's actually use of that now in an experimental feature in the SIF package, and this is related to actually the SIFT scanning bill of material stuff that Adam was talking about, but obviously it does have broader implications with Singularity 2 down the line. What I'd say is that the discussion about where we're going in the roadmap kind of and then Dave, what you're saying about squash fuse, and we're also looking at squash fuse over here, shows that there's quite a bit of kind of energy at the moment in development. And although you're from a different side of the fork, we can all look at each other's PRs because of the beauty of open source, and certainly we do, and we can kind of view it with regards to our roadmap and bring it in if it's beneficial, and likewise on your side. So it's a good place to be.
Yeah, and Dave, if you haven't seen the work in the Sylabs SIF side, it's well, one of the most recent PRs. I don't have the number off the top of my head, but yeah, I mean, it's kind of early experimental access just on the SIF tool side, but be interesting in comparing notes when you've got your PR open there.
I put in chat my work in progress PR. So
cool. Well, I think we're coming rapidly up on the top of the hour. So any other quick questions or anything? Okay, I'll make sure that the recording of this call goes up on YouTube as usual. And like I said, watch out for a 3.9.8 release of SingularityCE soon. And drop by the Slack or the Google Groups or anywhere else you find us if you have any questions about the things we discussed. Thanks for coming by, and thanks for the discussion, Dave. We'll say goodbye until next month.
Take care, everyone. Thanks.
All right.